In this part of my research work, I will talk about attribute modification, like how we can perform attribute in the face image. Like suppose this is our face image contains different attributes or different features, such as the color of the face, mustaches on the face, beard on the face. So in this work, I just implemented a deep learning network which can either remove some of the features, some of the attributes, or it can put some of the attributes on the face. Not only in the face, but it also include the hair color. So I will talk about this attribute modification network here. Actually, we presented this work in one conference in Japan. So I will talk about this attribute modification architecture in this presentation. In this work, we want to modify the different attributes of the face image while preserving the identity of a person. Secondly, the modification should be such that the attributes, the modified attributes should be prominent. Um, they should be well highlighted, whereas the other features of the face image are preserved. As an application, this work can be used as a tool for the detection algorithms in terms of identifying the suspect. Like suppose surveillance camera take a picture and the detection algorithm then identify the suspect. So by utilizing this approach, we can remove the eyeglasses, change the skin color, or change the hair color, so we can modify different information to improve the identification of the suspect. To do so, we propose GAN-based attribute modification network. The GAN-based attribute modification network consists of a single generator with a single encoder part. We can see here single encoder part. Similarly, it consists of two decoder part. Like this decoder is same, like they share their parameters, and the second decoder, and it also consists of two discriminator, this part and this part. The description of this architecture is given below, where this symbol show the encoder part of the generator. This show the latent representation. When the input image is given to the encoder, it encode that image to the latent representation Z, which is represented by the light blue color. And then every face image has its own attribute vector. This is given in the data set. So this color, the dark blue color, shows the given attribute vector, whereas the yellow and the green color are the modified attribute vectors. This show the decoder part. Similarly, in the discriminator, there are two parts. One is the attribute generation part, and the second one is the real or fake classification part, so which is shown here in the symbols. As I mentioned that the data set contains two kind of information. One is the face image, which is given here, and the second one is the corresponding attributes. Like this is this attribute vector represent this image. Like it says that this is the face of the male with the little brown hair, on closed mouth, without eyeglasses, without mustaches. So this attribute vector describe this image. Now what our algorithm does, like first it transform the input image XA to its corresponding latent representation in the first step. In the second step, we can see here it combined the transformed encoded latent space of the input image along with its attribute vector, and decoded it back to the original image. Similarly, in the third step, what we do, we apply a transformation function to the attribute vector and change it to B. And in the fourth step, we combine the transformed vector along with the encoded latent representation and decoded it back using the same decoder to the modified output image xb dash. In the fifth step, we again generate a new attribute vector, which is kind of a real representation. Like the previous attribute vectors are in binary form, here we made it in real by taking the average of the modified and original attribute vector, and then combine it with the latent representation and decode it back to the modified output. So in terms of the training, like we need different objective to train this architecture. So as I mentioned that this architecture consists of discriminator as well as generators. So we need to train both of these architecture. So in the first two objective we can see here are the training objective of the discriminator, both of the discriminator 1 and discriminator 2. Similarly, as I mentioned that each discriminator has attribute generation part. So these are the objectives for the generating of the real attributes, the given attributes, attribute A and attribute B. The overall objective for both discriminator are the combination of the four objectives described above here. Now the second step is the training of the generator. So the generator consists of the classical GAN objective. These are the GAN objectives. Similarly, we included the modified attribute generation objectives here, and then the reconstruction objective. The reconstruction objective is used to preserve the identity of the rest of the face image, and the overall objective of both the generators are given here. Once the training is done, we need to test, we need to inference the modified image from the given input image. So in this step, what we do, we just remove out the discriminator and only keep the generator. So discriminator is only used for the training of the this generator part. So in testing we don't need the discriminator. So what we do, we provide the input image to this generator, and we generate the latent representation, and then we select a required attribute vector and decode the attribute vector along the latent representation to the different modified output images. Like this is person with beard, bangs, black hair. So these are the modified images after training the architecture. Once the training is done, we also perform comparative qualitative analysis in terms of the baldness, in terms of different attributes separately. So in the first analysis we did we performed analysis in terms of the baldness, and we compared it with the existing ADGAN-based approach. So here we can see that ADGAN-based approach produces the baldness but not well defined, even though the identity of the face is well preserved. But in our case, the identity is slightly disturbed, but we can see the baldness is prominent. Similarly, we also did comparative qualitative analysis in terms of the gender. Like for example, if we provide male image, it should convert it, transform it into female face image. So here we can see that our architecture can effectively translate the male image to its corresponding female, and female to its corresponding male, as compared to the ADGAN-based approach. Next, we performed qualitative analysis in terms of the putting mustaches. Like here we can see that the input image without mustache. So this is ADGAN-based approach, and this is the proposed approach. So we can see the mustaches are prominent in our case, even though the face identity is slightly disturbed. We also performed the overall uh, analysis in terms of the 13 given attributes. So the first, these are the results from the again based approach, and these are our. So here we can see that in terms of all of the attributes, the proposed approach has well defined and prominent attributes translated to the input image as compared to the again based. Yeah, like we also we did analysis and we picked those example where our approach fails. So here we can see that we when we were putting the mustaches, some of the face identity are disturbed here. So these are the distortion in terms of our approaches. We collected those examples where our architecture produced distorted results. We also performed comparative quantitative analysis in terms of different attributes using the structure similarity index. So in this case, our uh, like we if the modification is prominent, the structure similarity index will be less. So we can see here that in terms of the Edgen based approach, the structure similarity index is less, both in terms of per pixel as well as per image, in our case for different 5 different attributes that we mentioned here. As a concluding remarks and future work, we proposed GAN based attribute modification network that consists of a generator with single encoder part and two decoders networks, two corresponding discriminators. The proposed GAN-based attribute modification network modify the attributes of the face image while preserving the rest of the identity of the face, and the modifications are prominent. But there are two main issues that I think we already discussed in the above slides. Like there is some distortion in the face image while we are modifying the attributes. So, as our future work, we are going to remove those distortion. Secondly, the important property is like interpolation. The current approach can only is kind of binary, like either put or remove. But we want to include a feature interpolation. Like if we want to we want to slightly remove or put something on the face image, change something in the face image. So this is feature interpolation.